Hey guys, in this video, we're going to do paper questions for IGCSE Cambridge Maths, paper code 0580. This is for extended. People who are preparing for the core exam, they can also use this video to practice questions for circle theorems. In this video, we're going to use exam questions from 2020 to 2025 to develop better understanding about circle theorems. So to fully understand this topic, you need to know all the circle theorems by heart. I'm attaching a link above for all the circle theorems that you can be tested on in your exam. So let's start with the first one. So this is one of the most basic ones. It says A, B, and C are points in a circle. AC is the diameter of the circle. We have to find the value of A. So you have to remember that angle coming out of the diameter, and if that angle is touching the circumference, that's always going to be 90 degrees. So this angle is always going to be a right angle, 90 degrees. So angle subtended from the diameter is always 90. This is one of the circle theorems. So if this is 90, this is 53, A is going to be 180 minus 90 minus 53, which is going to give us 37 degrees. That's your answer. And this one it says K, L, and M are points in the circle. KS is a tangent to the circle at K. Km is the diameter and triangle KLM is isosceles. We have to find the value of C. So for this, you need to know that the radius always makes a 90 degree with the tangent. That's another one of the circle theorems, that the radius always makes a 90 degrees with the tangent. And as we know, MK is the diameter, which the question clearly says, which means this is also going to be 90. So it's an isosceles right angle triangle. If this is 90, to find angle M, KML, that's going to be 180 minus 90 divided by 2. Why divide by 2? Because it's an isosceles triangle. So this angle is going to be the same as this angle. So that's 45 degrees. So this is 45 and this is also 45. Now 90 degrees, which is MKS, is 45 plus angle Z, which means 90 minus 45 is going to give us angle C. That is 45 degrees. For this question, you can use another circle theorem, which is the alternate segment theorem. Based on the alternate segment theorem, whatever angle is over here, that's going to be over here. This angle is going to be over here. And the middle one, which is MKL, is going to be common for the triangle and the straight line. Why? Because sum of angles in a triangle is 180 and sum of angles on a straight line is also 180. For this theorem to be valid, you need to make sure that a triangle is inscribed inside the circle and all of the vertices of that triangle are touching the circumference. If they are touching the circumference, you can use the alternate segment theorem to find the missing angles. If they're not touching the circumference, then you cannot use the alternate segment theorem in that case. Then the next type of question you get is about cyclic quadrilaterals. So the diagram shows a cyclic quadrilateral, find the value of I. So this is the third circle theorem. So far you've done angles in a diameter. So far you've done that angles subtended in the semicircle or in the diameter are 90 degrees. Then the radius makes a 90-degree angle with the tangent. You have done alternate segment theorem. So this is the fourth theorem. So this is the fourth theorem actually that you're learning now, which is the cyclic quadrilateral. In a cyclic quadrilateral, you need to have a quadrilateral inscribed inside the circle, and all of the vertices of that quadrilateral need to touch the circumference in order for it to be called a cyclic quadrilateral. If all of the vertices are touching the circle, then it's a cyclic quadrilateral. Once we have identified the cyclic quadrilateral, next thing you need to know is that opposite angles in a cyclic quadrilateral add up to 180 degrees, which means 4x minus 87 plus y equals to 180. And similarly, these two angles also add up to 180. So 2x plus x plus 60 also equal to 180. So we have two unknowns and the question is asking us to find the value of 5. As you can see, we cannot find the value of 5 without finding the value of x. So we solve this equation first. So 3x plus 60 equals to 180. 3x is 180 minus 60, which is 120. X is going to be 120 over 3, and that's 40 degrees. So now we do 4 times 40 minus 87 plus y equals to 180. That's 80 minus 87 plus y. So once again, in a cyclic quadrilateral, a quadrilateral needs to be inscribed in the circle. All of the vertices of the quadrilateral need to touch the circumference. And then we can say that opposite angles add up to 180. Then the next one is that in the diagram K, L, and M lie on the circle center O, angle KML is 2x. So this angle is 2x. And reflex angle KOL is 11x. We have to find the value of x. So this is another circle theorem where angle at the center is twice the angle at the circumference. So KOL, which is acute, is twice angle KML. That is a circle theorem. Angle at the center is twice the angle at the circumference. So that means 2 times 2x, which is 4x, is the inside angle over here. This is 4x. So KOL, the reflex angle, plus KOL, 4x, both of them add up to 360 because it's making a full circle. So 360 equals to 11x plus 4x, which is 15x. And then we do 360 divided by 15, and that gives us a value of 24. So the value of x is 24. So once again, angle at the center is twice the angle at the circumference. Another important thing, you need to make sure that they're coming out of the same chord. So KL is your same chord or segment, whatever you want to call it. So if there's an angle coming out of like the same chord, which is at the center, and another angle is coming out of the same chord, which is at the circumference, angle at the center will be twice the angle at the circumference. Okay, so now in this one, the points A, B, C, and D lie on the circle. PAQ is a tangent to the circle at A. EC is equal to EB. These two are equal, which means these two angles are going to be equal. So W is going to be 80 degrees because this is an isosceles triangle, EBC. Then ECB is given as 80 and angle AB is 40. So this angle is 40. We have to find the value of VWXYZ. So as I told you in alternate segment theorem, you need to have a triangle inscribed in the circle and the vertices need to touch the circumference. So E is at the circumference, A is at the circumference, B is at the circumference as well. So if this is 40, this is also going to be 40. So V is 40. And for W, I told it's an isosceles triangle, so it's going to be 80. Now for X, Y, and Z. If you notice, this is a cyclic quadrilateral. All four vertices are touching the circumference. So opposite angles add up to 180, which means Z plus 40 plus W is 180. So we know W, that's 80. That's going to be 180 minus 120, and Z is 60 degrees. Now we need to figure out x and y. We can see that we can use alternate segment theorem again on triangle EAD. Since this is 40, this is also going to be 40 because all three vertices are touching the circumference. So x is also 40. And now for y, we have another cyclic quadrilateral. This, this, and this. Again, all four vertices are touching the circumference. So 40 plus w, which is 120. If this is 120, this is 60. And this is 80. Y is going to be 180 minus 80, and that's 100. So these are your angles. As you can see, we had to apply cyclic quadrilateral 2 times, alternate segment theorem 2 times on the different shapes that are in the circle to figure out the missing angles. So by far, I think this was the most confusing question that I've seen in the past paper questions. Otherwise, they're quite straightforward. They don't make you apply like cyclic quadrilaterals or alternate segment theorems twice in most cases. Then if you look at this one, points A, B, C, D, E, and F lie on the circle center O. Find the value of X and Y. This is an interesting looking one. Angle at the center is twice the angle at the circumference. So this is the center. This one is the circumference. So X is going to be 110 divided by 2, which is 55. Then for the one above, ED is the same chord. So angles coming out of the same chord are equal, which means 24 is the same as y. This is another circle theorem. Angles coming out of the same segment. And if they're both going towards the vertex, this is another circle theorem that angles coming out of the same segment. And if they're going towards the circumference, they're going to be equal, which means y is equal to 24. At the first glance, it looked very weird, but like if you just break down the shape, you can see that. So for the first one, we can see that its angle at the center is twice the angle at the circumference. That's the circle theorem over there. And for the one at the top, ED is the same segment or chord out of which both the angles are coming out, and they're both at the circumference, which means they're going to be equal. So that's your answer. Then A, B, C, and D lie on the circle. PCQ is a tangent to the circle at P. Angle ACQ is given as 64. Work out the angle ABC giving reasons for your answers. So angle ABC, this one. So if this is 64, we know this is going to be 64 because alternate segment theorem, we have this triangle inscribed in the circle and all three vertices are touching the circumference. And then we have a cyclic quadrilateral. As you can see, all four vertices are touching the circumference. So which means opposite angles add up to 180. Hence, angle ABC is going to be 180 minus 64, which is going to be 116. So for your reason, because ADC equals to 64, because alternate segment theorem, and then 180 minus 64 equals 116 because ABCD is a cyclic quadrilateral. That's your answer. Then the diagram shows a circle center over diameter CE. A, B, C, D, and E lie on the circumference of the circle. Find the value of x, giving a reason for your answer. So for x, O is the center. And you need to realize that any line that's coming from the center and going towards the circumference is your radius. So OA and OB are both equal because they're the radius. You have to be very careful about this. Any line coming from the center going towards the circumference is the radius. So that means both of these angles are going to be equal because it's an isosceles triangle. So x is going to be 180 minus 2 times 24, which gives us 132 degrees. OA equals to OB, hence isosceles triangle. And find the value of y. So they said that EC is the diameter, which means this angle is going to be 90 because it's coming out of the diameter inside the circumference. So for y, it's going to be 180 minus 90 minus 73, which gives us 17 degrees. Because angles in a semicircle equal 90 degrees. What are right angles? That's your answer. Then draw a tangent to the circle at A. So you'll just use a ruler to draw a straight line that's tangent at A, like this. Then let's do some questions from 2021. So if you look at the first one, it says, A, B, and C are points on the circle center O. AC is the diameter of the circle and AB is a straight line. DC is a tangent to the circle at C. Write down the mathematical name for the line BC. BC is a chord. And explain why angle ABC is 90 degrees. ABC is 90. This angle is 90 because angles in a semicircle are right angles or 90 degrees. Then find the value of x. So like I mentioned before, any line coming from the center towards the circumference is going to be the radius. So OC is equal to OB equal to OA because they're all the radius. So they're all equal, which means we have two isosceles triangles. If this is 46 and this is 90, we know this is going to be 46 because it's an isosceles. So then CBO is going to be 90 minus 46, which equals 44. So if this is 44, this is also going to be 44. So x is going to be 180 minus twice of 44. That gives us 92 degrees. That's your answer. And then for the value of y, if angle CBA is 90, this is going to be 90 as well because this is a straight line. ABD is a straight line just given in the question. And then we know that DCE is a tangent and OC is the radius. So we know that the tangent makes a 90-degree angle with the radius. So this angle is going to be DCB is going to be 90 minus 44, which is 46. You can also use alternate segment theorem over here because we have a triangle inscribed in a circle and all three vertices are touching the circumference. So this is the same as this. So y is going to be 180 minus 90 minus 46. That gives us 44 degrees. So that's your value of y. Then this one it says that ABC and D are points in the circle center O. Angle COD is given as 124 and BCO is 35. You have to find the angle CBD. This one is going to be 124 divided by 2. Why? Angle at the center is twice the angle at the circumference. So that's 62 degrees. CBD. Angle at the center is twice the angle at the circumference. That's your reason. Then it says work out angle BAD, give a geometrical reason for each step of working. BAD is this one now. So we know this is 124, and as we know, OD is equal to OC because there's a radius. So that means we can find angle OCD, which is 180 minus 124 divided by 2. That gives us 28 degrees. So this is 28, and so is this. Again, this is a cyclic quadrilateral because ABCD are the vertices of a quadrilateral and they all touch the circumference. So 35 plus 28 equals to, so 35 plus 28 plus angle A equals to 180. So 180 minus 35 minus 28, and that gives us the value of 117. So 117 degrees is the value for angle BAD. And first reason was that OD equals to OC, so it's an isosceles triangle. And then it's a cyclic quadrilateral. And a cyclic quadrilateral opposite angles add up to 180. That's your answer. Then it says A, B, and P are points in a circle center of an angle OB equals to 38 degrees. Find angle APB. So for APB, which is this one, if you look at this triangle, it's an isosceles triangle because OA equals to OB because again, it's the radius. If you realize it's the same type of thing being repeated every single year. So that means OAB is also going to be 38. Hence, angle AOB is going to be 180 minus twice of 38, which gives us 104. So this over here is 104. So now angle at the center is twice the angle at the circumference, given that both the angles are coming out of the same chord, and one angle is at the center and the other is at the circumference, which means APB is going to be 104 divided by 2, which is 52 degrees. That's your answer. So 3 marks, 3 different theorems. Then CDEF is a cyclic quadrilateral. FC equals to FE. This is equal to this. DU is a tangent to the circle at C. And angle TCF is given as 50. So this is 50. Find angle EFC. This is the angle they're asking us to find. So again, we have alternate segment theorem because it's a triangle inscribed in a circle. And if this is 50, this is going to be 50 as well. And since FC is equal to EC, that means it's an isosceles triangle. Hence, EFC will also be 50. Then angle CDE. So for CDE, this one, they said that CDEF is a quadrilateral and a cyclic one. So Let's highlight that. So we know opposite angles add up to 180. This was 50. So CDE is going to be 180 minus 50, and that's 130. That's your answer. So far, it's the same thing repeated again and again. Nothing very odd yet. Then this one, points E, F, G, and H lie on the circle and EG equals to EH. HF and EG intersect at K. ET is a tangent to the circle at E. Angle FET is given as 47 degrees and FEG is 25 degrees. Find the value of X. This is a triangle inscribed in a circle. So you can use alternate segment theorem. Some of this is going to come over here. So EHG is going to be 25 plus 47, which is 72 degrees. So this is 72 degrees. Since it's an isosceles triangle, this is also going to be 72 degrees. So X is going to be 180 minus twice of 72. And that gives us 36 degrees. That's your angle X. Again, the same theorem. Alternate segment theorem and cyclic quadrilateral is very commonly used in questions. Then this one says points A, B, and C lie on a circle, center O. Angle AOC is 142 degrees. Find the value of Y. So in this type of question, you always use angle at the center is twice the angle at the circumference, but you need to look at the direction. If this is the center, then angle at the circumference is going to be this one. But if you go in the opposite direction, if this is the angle at the circumference, this will be angle at the center. So whenever you see something like this, you have to make sure that the angles are in the same direction. They're not going to be in opposite directions. So first we'll find reflex angle AOC 360 minus 142, which is going to be 218. Now angle at the center is twice the angle at the circumference, which means y is going to be half of 218, which is 109 degrees. Again, you need to see the direction of your angles. Angle at the center is twice the angle at the circumference. This is for this. And if it's on the opposite side, it's this and the reflex angle. If you don't get this right, you won't get the marks for this one. This one, it says A, B, C, and D are points in a circle. D is a tangent to the circle at D. DA is parallel to CB. Find the value of X and Y. So if you notice, we have parallel lines, we have a tangent, and we have a cyclic quadrilateral as well. So let me highlight that. This is your cyclic quadrilateral. All four vertices of the quadrilateral are touching the circumference. That's very important. So if this is 60, this is going to be 180 minus 60, which is 120. And also if you notice, DCA is a triangle inscribed in a circle. So we can use alternate segment theorem over here, which states that this angle is going to be this angle, and this angle will be this one. So based on that, X is going to be 38. And the reason is alternate segment theorem. You don't have to give the reason over here. Once again, I'm giving the reason for your understanding. Then for y, we know DA is parallel to CB, which means this angle is going to be the same as this angle because they're alternate angles. So this is also 38. So to find y, we can see that ABC is a triangle. So we do 180 minus 120 minus 38, which gives us a value of 22 degrees. That is your final answer. Then this diagram shows a circle and 8 chords. Calculate the value of u, v, w, and x. So this might look confusing, but you have to break down the shape. So for u, you need to see that this is your chord and angles coming out of the same chord, given that they're going towards the circumference, are equal, which means this is going to be the same as this. So u is 20 degrees. Then for v, we can find this angle first because we have a triangle over here. And as you know, this angle and angle V are coming out of this same chord, which is this one. So again, this angle and angle V are going to be equal. So let me call this A. So A is going to be 180 minus 72 minus 56, which gives us a value of 52. So if this is 52, V is also going to be 52. So far, we've used the same circle theorem in this question, which is angles coming out of the same chord. If they're going towards the circumference, they're going to be equal. Now we know u, which is 20. We know this angle. We know 72. We can find x because again, we have a triangle. So we can say x is going to be 180 minus 72 minus 52 minus 20. Let me highlight that triangle for you. This is the triangle I'm talking about. We have 72, we have 52, we have 20. We need to find x, so we can easily find x by subtracting these angles from 180. That's 36. Now for w, again, angles coming out of the same chord are equal. So this is going to be 72. And then if you notice, we have a cyclic quadrilateral as well. All four vertices of this quadrilateral are touching the circumference, which means W is going to be 180 minus 72 because opposite angles add up to 180 in a cyclic quadrilateral. So that's going to give us 108 degrees for W. So two circle theorems in this question. We have angles coming out of the same chord are equal and then a cyclic quadrilateral. Then G is a point in the circle center O. FAG is a tangent to the circle at G and OH equals to HG. Write down the mathematical name for triangle OHG. So if you have two equal lengths, that's an isosceles triangle. Then find the value of x. For the value of x, OG is the radius and FG and FHJ is a tangent. So the radius always makes a 90-degree angle with the tangent. If OHJ is an isosceles, x is going to be 28 degrees because the angles opposite to the equal lengths are also going to be equal. So x is also 28. Then you have to find the value of y. So for y, we're going to do 180 minus 90 minus 28 and again minus 28. We're going to use this, this, and this because it's a triangle, OGJ. So since OGJ is a triangle, We use the given angles to find the unknown. So that's going to give us 34. That's your value of y. That's how you solve this. Then points P, Q, R, and S lie on a circle with diameter PR. Work out the size of angle PSQ. This one. You have to give a geometrical reason for each step of working. So if PR is the diameter, that means PQR is going to be 90 because angles coming out of a semicircle are 90 degrees given that they're at the vertex. So this is 90. So you can find the third angle, which is going to be 180 minus 90 minus 29. That gives us a value of 61. So this is your angle PRQ. That's 61. So if this is 61, we know angles coming out the same chord are equal. So this is also going to be 61. So first step is going to be PRQ equals to 61 because angles in a semicircle are right angles. Then PSQ equals 61 because angles in the same chord are equal. That's your answer. Then the points A, B, and T lie on a circle and CTS is a tangent to the circle at T. ABC is a straight line, AB equals to BT. So these two are equal. Angle ATS is 98 degrees. Work out the size of angle ACT. This is what we're trying to find. We have a triangle inscribed in a circle. So we can use alternate segment theorem. If this is, so we can use alternate segment theorem. If this is 98, this is also going to be 98. Hence, and since this is an isosceles triangle, 180 minus 98 divided by 2 gives us angle BAT, 41 degrees. So alternate segment theorem is a theorem that is very commonly used. So is the cyclic quadrilateral and angles coming out of the same chord. These three are very commonly used. So we have these two angles. This is 41 and this is 41. So to find ACT, we know that if this is 41, this is also going to be 41 because alternate segment theorem. And the question has said that ABC is a straight line. That means we can do 180 minus 90 to find angle CBT. Because sum of angles on a straight line is equal to 180. So that's going to be 82 degrees. So now CBT is a triangle. So now we know ACT is a triangle, CBT is also a triangle. So we can use either of the triangles to find the value of angle ACT. So you can use either of the triangles to find the value of ACT. So if I use CBT, ACT is going to be 180 minus 82 minus 41. Either way, it's going to be the same thing. That gives us 57 degrees. That's your value of angle ACT. Simple as that. Then this one, the diagram DEF are points in a circle with center O. AB is a tangent to the circle at E. Lines AB and CD are parallel and angle BED is 68 degrees. So if they are parallel, this is also going to be 68. And we know that this is the diameter FE. So the total angle FDE is going to be 90, which means FDC would be 90 minus 68, which is 22. The question is saying find angle CDE, give a reason for your answer. CDE would be 68. Because alternate angles are equal in parallel lines. That's your answer. This angle is alternate to this one. Then DEF, DEF. This is 68. This is also going to be 68. Why? Alternate segment theorem. We have a triangle inscribed in the circle, and all three vertices are touching the circumference. So for DEF, we do 180 minus 90 minus 68. That gives us 22 degrees. Alternate segment theorem. And angles in a semicircle are 90 degrees. That's your answer. And work out EFD. EFD, 68. For DEF, we could have also subtracted 68 from 90 because it's the radius touching the tangent. So again, 90 degree. So you can also say that radius makes a 90-degree angle with the tangent. So any way you're solving it, you'll get your mark as long as the reason is justified. So for EFD, alternate segment theorem, and angles in a semicircle are 90 degrees. You can write these over here as well. That's your answer. Then this one it says A, B, C, D, E, F, and G, H, K are triangles with all vertices on the circumference of a circle. From the list, draw a ring around the line that is the diameter of the circle. So for that, this is 8. These two are 85. This is 82. This is 94. So find this angle, A, B, C. That's going to be 180 minus 94 minus 6. That gives us 80 degrees. So this can't be the radius because we know that. So this can't be the diameter because we know the angle coming out of the diameter, if it's touching the circumference, is going to be 90. If we try to find this one, DFE, that's 180 minus 82 minus 8. That's going to be 90 degrees. This one is giving a 90, which means DE is the diameter because the angle coming out of this, which is going towards the circumference, is 90 degrees. So this line is the diameter. Then in this one, ABCD is cyclic quadrilateral, which is already given the question. ABX is a straight line. PQ is the tangent of the circle at A. CBX is given as 85. BAQ is given as 55. Find angle CA. And angle CAD is given as 42. You have to find angle CBD first. This is the angle. DC is a chord. If this is 42. An angle coming out of the same chord is also going to be 42. So this is 42. Angles in the same chord are equal. That is the reason. Then ACB. Where is A? ACB. This one now. That's 42. And this is what we're trying to find. ACB. That's going to be 55. Alternate segment theorem. There's a triangle inscribed in the circle. All three vertices are touching the circumference. So this angle is the same as this one. Then ADC. ADC, this one. So we said this is 42, 55. We can find this angle first, which is going to be DBA. That's 180 minus 85 minus 42. That gives us 53 because angles in a straight line add up to 180. So since ABCD is cyclic quadrilateral, opposite angles add up to 180. So ADC is going to be 180 minus 42 minus 53. That equals to 85 degrees. That's angle ADC. Then says angle BCD. So for angle BCD, first we find this angle, which is going to be CAD. That's 180 minus 55 minus 42 minus 53. That's going to be 30. So this is 30. So to find BCD, again a cyclic quadrilateral. So BCD is 180 minus 42 minus 30. That gives us 108 degrees. So that's your angle. Then PAD. Simple, we do 180 minus 42 minus 30 minus 55 because again a straight line. That equals 53 degrees. That's your answer. Then AB, C, and D are points in a circle. AB is parallel to DC and angle ACD is 32. Chords AC and DB intersect at E. We have to find the value of X. So if DC and AB are parallel, this is going to be 32 because alternate angles are equal. This is going to be X because vertically opposite angles are equal. And if we join CB, it's also going to be another chord. And we know angles coming out of the same chord are equal if the angles are on the vertex. So this is also going to be 32, which makes this an isosceles triangle. Same goes for this. This is also going to be 32. So X is going to be 180 minus 32 minus 32. That's 116. In case the chord isn't given, but you can see that it's using the same property, you can join the points to make your own chord. That's completely fine. As long as you're justifying your answer correctly, they will give you the mark. DA can be joined to make a chord as well. CB can be joined to make a chord as well. And then you can see that it uses the circle theorem where angles coming out of the same chord are equal. So that's how you solve this one. Then A, B, and C are points on the circumference of a circle center O. Tangent DE touches the circle at C. Angle BC is 53 and angle ACO is 20. Find the value of x. Firstly, OC is your radius and DC is a tangent. So we can find OCB first. So since OC is the radius and DC is the tangent, OCB is going to be 90 minus 53 because the radius and the tangent make a 90-degree angle at their intersection. So this is 37 degrees. Since OC equals to OB because they're the radius, so this is also going to be 37. Because if the lengths are equal, angles are also going to be equal, which makes it an isosceles triangle. So you can find the third angle now, which is COB. That's going to be 180 minus 37 minus 37. That gives us 106 degrees. Now we can find this angle because angle at the center is twice the angle at the circumference. So CAB is 106 divided by 2, 53 degrees. Now what we're going to do next is we're going to join A and O, and we have another triangles, triangle AOC and triangle AOB. AO is also equal to OB and OC because again the radius. So if this is X, this is also going to be X. And if that's 20, this is also going to be 20. So we can do 53 minus 20 to find the value of X. Because the total angle CAB is 53. A part of that is 20. And a part of that is X. So 53 minus 20, which is 33. That's X. That's your answer. So in case you don't understand the question, but you still know how to find some of the missing angles, just solve that. You never know, it might be useful in finding the actual answer, but you haven't just figured out how to find it. So if you have done that, at least you will get a mark for that. It's always better to score something instead of nothing. Then look at this one. It says points A, B, C, D, and E lie on a circle. FG is a tangent to the circle at D. EB is parallel to DC. Find the value of W, X, Y, and Z. You must have realized by now that I've chosen all of the most weird looking questions from the past papers so that if anything similar comes in your exam, you know how to solve this. And the reason why we're going from 2020 to 2025, because obviously they're not going to give the same type of questions for each topic in your exam. So it's going to be something from 2020 or 2021, 22, 23, but not 2025 and 2024. So that's why I'm going to solve those questions at the end, but the older ones first, so that in case anything similar comes, you know how to figure it out. And also the older ones are more difficult than the new ones as well. So W, X, Y, and Z. Let's start with W. We know that there's a triangle inscribed in a circle. All three vertices are touching the circumference. So we can use alternate segment theorem. W is the same as 20. So we have our first angle. And the reason is alternate segment theorem. We have angles coming out of the same chord. The chord is ED. And both the angles are going towards the circumference, which means they're equal. So X equals to W. Hence, it's also going to be 20 degrees. Angles in the same chord are equal. Remember that this doesn't apply to angles at the center or twice the angles at the circumference. Yes, they're also coming out of the same chord, but the two angles or any of the angles, they need to be on the circumference for them to be equal. One can't be at the center or in somewhere in the middle and the other at the circumference. Then it doesn't apply. This circle theorem only applies if both the angles are at the circumference. Now for angle Y, this is 20, this is 20. For angle Y, we can see that we have two parallel lines. EB is parallel to DC. So this is also going to be 20 because alternate angles are equal. And which means all of this added will be Z because alternate segment theorem. That's 45 degrees. Alternate segment theorem. That's 45. And then for angle Y, what we can do is if we find this angle, that's going to be EDB. That's 180 minus 20 minus 20 minus 25. That gives us 115. We know in a cyclic quadrilateral, opposite angles add up to 180. So we can say 180 equals to ACD plus AED. Okay. So ACD is 75 and AED, we don't know, but we know part of it is 45. So we can say A plus 45. This is angle A. So 180 minus 75 minus 45 is angle A. That's going to give us 60. So this is 60. So now using the alternate segment theorem, so let me highlight it again. This triangle. And using alternate segment theorem, we're saying this is the same as this. Okay. So that means 60 plus 45 is the same as Y plus 20 plus 25. So 105 minus 45 equals to Y. 60 degrees. That's your value of Y. And that's your answer for this question. It's slightly confusing, but once again, you have to break it down, do it step by step. If you don't do it step by step, you're bound to get confused. And for 2024 ones, I'm just going to do the ones that are very difficult. I'm not going to do the ones that are being repeated because otherwise this video will be very long and it already is. So in this one, it says A, B, C, and D are points in a circle. PQ is a tangent to the circle at A. B, M, N, D is a straight line. Angle ACD is 49 degrees and AMB is 105 degrees. Angle PAB is 45 degrees. Find the angle BAM. So that's this one. So we know angles in the same chord are equal. So if this is 49, this is also going to be 49. So we have two angles. We can find the third one using sum of angles in a triangle. That gives us 26 degrees. That's BAM. And find angle BAD. BAD. All of this. So we have this as 26. And we can see that we can use the alternate segment theorem again on triangle BAD. This was 49 and this will be 45. This is the same as this. So we can find BAD 180 minus 45 minus 49. That equals 86 degrees. Then give a geometrical reason why BD is not the diameter of the circle, because BAD is not coming out to be 90 degrees. Is not 90 degrees. Angles in a semicircle are always 90 degrees. Since this one is coming out to be 86, that's less than 90. So it's not so that's why BD is not the diameter. Then this one it says A, B, C, D, and E lie on a circle. FG is a tangent to the circle. BAD is 110 and ADB is 20. BC is 45. Find angle BCD. BCD, this one. We have a cyclic quadrilateral. So that's going to be 180 minus 110 because opposite angles add up to 180 in a cyclic quadrilateral. So 70 degrees. Opposite angles add up to 180 degrees in a cyclic quadrilateral. Then find angle DBC. DBC, this one. So this is 70. This is from the same chord, which is BC. So this will also be 45. So DBC is going to be 180 minus 70 minus 45. That gives us 65 degrees. That's 65. Then DCG. This is DCG. That's going to be 65 because alternate segment theorem. That's 65. Then A, B, and C are 3 points on a circle with center O. DE is a tangent to the circle at A. Angle ACO is given as 35 and angle BCO is given as 40. Find angle AOC. Now, this question is very similar to a question that we've already done in one of the previous papers. And I just wanted you to realize the pattern. They're the same type of questions. Once you will download this document as well, you will see that it's the same type of question repeated again and again. So I would advise do the older questions first and then go towards the newer one because then you will see how simple it is. It's not that complicated. So angle AOC, we know OC is equal to OA because of the radius, which means it's an isosceles triangle. So this is going to be 35. So for AOC, it's going to be 180 minus 35 minus 35. That gives us 110. Then ABC. This one. Angle at the center is twice the angle at the circumference. So 110 divided by 2, 55 degrees. Then DAC, that is this one. We know O is the radius. Radius makes a 90-degree angle with the tangent. So 90 minus 35. 55 degrees. For this, you can also use alternate segment theorem. This angle will be the same as this, so we can also use that as well. Either way, it's correct. And then angle OAB. So that's this one. Let me erase all of this first. Angle OAB is this. So we will draw a line over here. We know this is 40, so this is also going to be 40 because we have 3 isosceles triangles. So total angle was 55. So we do 55 minus 40, and that gives us the answer. Again, this is exactly the same as the question that we've done in the previous questions. And this one, it says A, B, C, D, and E lie on a circle. Find the values of X, Y, and Z. Okay, so for this, firstly, Y is going to be 52 because AB is the chord and we have angles coming out of the same chord. So Y is 52. For X, we have a triangle. So we can do 180 minus 125 minus 1 minus 26. Let me highlight that. This is your triangle. So X is going to be 180 minus 125 minus 26. That's 29 degrees. That's your X. Now for Z, we do have a cyclic quadrilateral, and I'm going to pick this one. So using the triangle inside this, so using this triangle first, I'm going to find angle EAC. So angle EAC is going to be 180 minus 26 minus X minus Y. So we know X and Y are 29 and 52. So that gives us 73 degrees. So now in a cyclic quadrilateral, opposite angles add up to 180. So Z equals to 180 minus 73, and that's going to be 107. So 107 degrees is your value of Z. Then this one, it says A, B, and C lie on a circle with center O. D is a tangent to the circle at C. Angle ABC is 52 degrees and angle BC is 65 degrees. Find the value of X and Y. So again, the same thing. X is going to be 52 times 2 because angle at the center is twice the angle at the circumference. That's 104 degrees. Angle at the center is twice the angle at the circumference. Then find the value y. This is 104. We can find these two angles first. OAC is going to be 180 minus 104 over 2. That gives us 38. That's 38. So ABC is a triangle inscribed in a circle. So this is the same as this. So y is going to be 65 minus 38. 27 degrees. That's your answer. And with that, we're done with questions for circle theorems. As you can see, we did several past paper questions from 2020 to 2025. This was the October-November 2025 one actually. So if you have any questions or confusions, please leave a comment below and I'll help you out. If you understood everything, please like and subscribe. Share this video with your friends and don't forget to check out the other videos in this playlist. And as you can see in the description, I've attached the link to the document that you can download for this video, and then you can practice all of these questions on your own as well and see if you understand this topic or not.